Welcome to Rex Science Forum. Today, we introduce an essential topic in organic chemistry, the homologous series. Understanding homologous series will provide you with a strong foundation in organic chemistry, allowing you to identify patterns in molecular structures and predict chemical behaviors with ease. Objective: by the end of this tutorial, you should be able to understand the concept of homologous series and how organic compounds are classified. Explore the alkyl groups and functional groups that influence the physical and chemical properties of organic molecules. Analyze the effects of alkyl and functional groups on molecular behavior. Examine examples of homologous series derived from alkanes. The homologous series. Organic compounds can be grouped into a small number of families known as homologous series. Members of the same series share a general molecular formula. Alkanes, the simplest series, have a general formula of CnH2n plus 2, where n is a whole number starting from 1. Each compound within a homologous series is called a homologue. Successive members in a series differ from the previous one by CH2 unit. Definition: a homologous series is a family of organic compounds that follows a regular structural pattern, where each successive member differs in its molecular formula by CH2. List of homologous series. Alkanes, CnH2n plus 2. Alkenes, CnH2n. Alkanols, alcohols, CnH2n plus 1OH. Carboxylic acids, CnH2n plus 1COOH. Characteristics of homologous series. Each successive member differs in molecular formula by a CH2 unit. All members of the same series share a general molecular formula. Each successive member differs in relative molecular mass by 14, C equals 12, H equals 1 times 2. Physical properties change gradually as the number of carbon atoms increases. Example: in alkanes, boiling points, melting points, and density increase down the series, while solubility in water decreases. Chemical properties remain similar but vary slightly along the series. Alkyl group. An alkyl group is derived from an alkane by removing one hydrogen atom. It follows the general formula CnH2n plus 1. The univalent group which is formed from an alkane by the loss of a hydrogen atom is known as the alkyl group. The compound that is formed by substitution can be considered as being made up of the alkyl group and the substituent group. For example, chloromethane, CH3Cl, is composed of the methyl group, CH3, obtained from methane, CH4, by the loss of a hydrogen atom linked to the substituent chlorine atom Cl. Alkyl groups are named by replacing an in alkanes with Yl. Alkyl groups are given the general symbol R. Examples of alkyl groups: methyl CH3 from methane CH4. Ethyl C2H5 from ethane C2H6. Propyl C3H7 from propane C3H8. Butyl C4H9 from butane C4H10. Functional groups. A functional group is a specific atom, radical group of atoms, or bond in an organic molecule responsible for its chemical properties and reactions. Functional groups determine the class of organic compounds, such as alcohols, acids, and ketones. Examples of functional groups: hydroxyl OH in alcohols, example ethanol C2H5OH. Carbonyl CO in aldehydes and ketones, example propanone CH3COCH3. Carboxyl COOH in carboxylic acids, example ethanoic acid CH3COOH. Amino NH2 in amines, example methylamine CH3NH2. And the double covalent bonded carbon atoms. Effects of alkyl and functional groups. Alkyl groups mainly affect physical properties like boiling points and solubility. Functional groups determine chemical behavior. Example: the OH group makes alcohols soluble in water. Thank you for watching. Please like, comment, and share this video.